Okay, fifth graders, we're starting Chapter 4, Section 1. And this section is all about multiplying numbers, specifically decimals, by the power of 10. And I think, if I recall, I think kind of early on in the year we touched on this, but it wasn't with decimals. And this example they give here could be a little bit confusing, but let's look at a couple things here and we'll see what happens. Look at in box C here. It says 3.63 times 1 is obviously the same thing, 3.63. Then they have 3.63 times 10. And just remember that something, let's say a number, let's say 17 times 10, that's the same thing as if you see 17 times 10 to the first power. 10 is equal to 10 to the first power. So don't let that ever confuse you. If you see one number being multiplied by 10 and another one being multiplied by 10 to the first power, it's the same thing. So 3.63 times 10. Look, they moved the decimal just one place to the right, so it becomes 36.3. And then here, times 10 squared, they've moved the decimal 2 places. And here, they've moved the decimal 3 places. So let me give you my own example. What if I had a number, let's say 27.22, and I was to multiply that by 10. So that's going to be 272.2. You can see that I moved the decimal one place. Now if I was to multiply this by 10 squared, then my answer would be a little bit different. We have 27.22. I'm going to move the decimal 2 places. 2 places. So now it's going to become 2,722. Put a little comma there. What if I was to multiply that 27.22 times 10 to the third power? Well, how many places do you think I'm going to move? 1, 2, 3. So actually I have to add a 0. It becomes 27220. It becomes 27,220. So for each exponent, that's how many places we move the decimal. And you'll notice that as we move the decimal further to the right, it gets larger. And whenever we move the decimal to the left, it gets smaller. So for example, if I just had a number here, let me just come up with any number here. How about 288.36? If I move the decimal one place to the right, which makes it 10 times larger, it's now 2,883.6. But if I was to move the decimal one place to the left, right here, it would become 28.836, which is a lot smaller, 10 times smaller. Each time we move it to the right, it's 10 times larger. Each time we move the decimal one place to the left, it's 10 times smaller. So I think that'll help you guys, if you can remember that, answer most of these questions here. Let's take a look at some of these. The convince me at the bottom of that page there, it says complete the chart. So it looks like in the first column they're all 10 times larger. In the second column, 20 times larger, 30 times larger, or actually 300 times larger, and 200 times larger. or 2, well, I'm not sure if I'm saying that right. It would be 10 times larger, and then 100 times larger, and 1,000 times larger. 10, 100, and then 1,000 times larger. Yeah, I wasn't saying that correctly first. So the very first one here, 1.275, that would become 12.75. I move the decimal one place to the right. And then this one here would become 127.5. And then finally, it would end up being 1,275. Notice each time I'm moving the decimal one place to the right. So let's look at the guided practice here. So number 1, it says when multiplying by the power of 10, like 4.58 times 10 to the third, how do you know you're moving the decimal in the correct direction? The number should be getting what? Larger. Okay, find each product. I'm looking at 2 through 5 here. Well, let's look at number 3, for example. So the number is 3.1, and it's times 10 to the third power. How many places do we have to move the decimal? Looks like 3 places. So 3.1, I'm going to move the decimal 3 places. 1, 2, 3. So it looks like I'm going to have to add 2 zeros and put the decimal right there. So what does that make it? 3,100. And you know the decimal would be right there. But you really wouldn't bother writing the decimal. It's assumed to be at the far right of the number. Okay, so just move the decimal the number of places that the exponent is. How about number 4? Number 4, it's 0.062 times 10 squared. I'm going to move the decimal 2 places. 1, 2. So it becomes 6.2. And what was this one? It was 3,100. All right. How about number 7 here? Let's look at number 7. So 0.086 times 10 to the first, or just times 10. So I'm going to move the decimal 1 place over. It's going to be right before the 8, so it becomes 0.86. And the 0.086 times 100 is the same thing as it's the same thing as 10 squared. So I'm going to move it 2 places, so it looks like it's going to become 8.6. And then here it's the same thing as 10 cubed, 10 to the third power. So that's going to become, looks like, 86. But number 10 here, 0.365 times 10 to the fourth. So I'm going to move the decimal 4 places. 1, 2, 3, and then I'll have to add a 0. So it's going to become, looks like 3,650. You know the decimal would be right there, but you wouldn't bother putting it there. And let's look at the last page here. I think you guys can do the rest of those on your own. Let's see here. Number 19, Monroe uses a microscope to observe specimens in a science class. The microscope enlarges the objects 100 times. That's going to be the same thing as 10 squared. Their actual size. So find the size of each specimen as seen in the microscope. So they're all going to be 10 squared or 100 times larger. That means we're going to move the decimal 2 places. So specimen A here would now be what? 0.8. Specimen B, 2 places, would be 1.1. I'll let you fill out the rest. And it says Monroe's teacher wants each student to draw a sketch of the longest specimen. Well, which one's the longest? Well, actually, it looks like I'm going to have to finish this chart with you guys here. I'll move it 2 places, and this is going to be... Oh, no, I don't, actually. The actual length, and they want which specimen is the longest. So we're going to compare all of those. How do you compare decimals? This is chapter 2, I think. I'm going to write the first one, 0.008. What's the second one? 0.011. What's the third one? 0.0025. And the last one is 0.004. And I can add a 0 here just to kind of help keep things lined up. Now let's just do a comparison. These are all the same, it doesn't matter. Those are all the same, it doesn't matter. Oh, which is the largest? Well, obviously that one, which is the second one, which is B. So which specimen is the longest? That's the question for number 20. And it looks like specimen B is the longest. Let's see. Seen through a microscope, a specimen is, now it would be as if it's in this column. What would its actual length be? So think about it. You're now doing the opposite of what we've been doing. So which way would the decimal go? Because the actual length is going to be smaller, so it's going to go to the left. So I won't answer that. I think you guys can figure that out and put your answer in there. Number 22, yeah, you could do that one. 23, Jeffrey Drew, yeah, Brittany. Okay, so 23. Let's look at 23 for a second here. Jeffrey drew a line that's 9.5 inches long, and Brittany drew a line that is 10 times as long. So it's 10 times larger. What's the difference in length between the two lines? Well, first off, if we have a line that's 9.5 and I needed to make that 10 times larger, which way am I going to move the decimal? That way. So it's going to become 95. And now they're asking, what's the difference? Well, whenever we talk about difference, we're talking about subtraction. So it's going to be 95, and we're subtracting 9.5. And I can put a decimal there and put a little placeholder 0, because you always got to keep your decimals lined up when you're adding and subtracting. And I'll let you guys figure out what that answer would be. So let's see here. Let me move this up a little bit further. What else have we got? Yeah, who ran further? Which is larger, 2.6 or 2.60? Does that 0 change the value? No. So you can figure that one out. Explain your reasoning. And then looks like 25, 26 are multiple choices. So that's it. And we will grade this on Wednesday morning.